Welcome to a new session on the massive open online course Introductory Concepts of Digital Computing offered by Swayam. In this session, we are going to discuss a new combinational circuit demultiplexer. It performs a similar function as that of decoder, which we have already discussed. As we have already completed the session on multiplexers, it would be more easy to understand the concepts. Demultiplexer. In the previous class, we learned about multiplexer or MUX, which is a combinational logic circuit that selects one of many inputs and results with a single output. MUX is the device responsible for multiplexing. The operation of a demultiplexer is exactly the opposite to that of a multiplexer. As an inverse to the MUX, demux is a one-to-many circuit. With the use of a demultiplexer, data from one input can be passed to one of the many output data lines. Demultiplexers are mainly used in Boolean function generators and decoder circuits. Different input-output configuration demultiplexers are available in the form of single integrated circuits. Also, there is a facility of cascading two or more demux circuits to generate multiple output demultiplexers. What is demultiplexing? The process of getting information from one input and transmitting the same over one of many outputs is called demultiplexing. If you recall the topic multiplexer, there we discussed the concept of multiplexing. Demultiplexing is just the opposite of that. A demultiplexer is a combinational logic circuit that receives the information on a single input line and transmits the same information over one of n possible output lines. In order to select a particular output, we have to use a set of select lines, and the bit combinations of these select lines control the selection of specific output line to be connected to the input at a given instant. If multiplexers are called as data selectors, then demultiplexers are called as data distributors, since they transmit the same data which is received at the input to different destinations. Thus, a demultiplexer is a 1 to n device, whereas the multiplexer is an n to 1 device. The figure shows the block diagram of a demultiplexer or simply the demux. It consists of one input line, n output lines and m select lines. In this, m select lines are required to produce 2 raised to m possible output lines. For example, a 1 to 4 demultiplexer requires 2 select lines to control the 4 output lines. I told you that demultiplexer means one to many. It takes data from one line and distributes them to given number of output lines. A demultiplexer is a circuit with one input and many output. By applying control signal, we can steer any input to the output. Few types of demultiplexers are 1 to 2, 1 to 4, 1 to 8, 1 to 16 demultiplexers. 1 to 2 demultiplexer. What does 1 to 2 demux means? Yes, it means one input line and 2 output lines. A 1 to 2 demultiplexer consists of one input line, 2 output lines and 1 select line. The signal on the select line helps to switch the input to one of the 2 outputs. The figure given here shows the block diagram of a 1 to 2 demultiplexer with additional enable input. In the figure, there are only 2 possible ways to connect the input to output lines. Thus, only one select signal is enough to do the demultiplexing operation. When the input is low, then the input will be passed to Y0, and if the select input is high, then the input will be passed to Y1. The truth table of a 1 to 2 demultiplexer is shown here, in which the input is routed to Y0 and Y1 depending on the value of select input S. We can derive the Boolean expressions for the outputs as follows. Assume S is the select input, D the data input and Y0 and Y1 are the outputs of the demultiplexer. From the table, the output y naught is active when the combination of select line and input line are active low and high respectively, that is S D equal to 0 1. Therefore, the expression for output y naught is y naught equal to S complement D. Similarly, the output y1 is active when the combination of select line and input line are active high, that is SD equal to 1 1. Therefore, the expression for output y1 is y1 equal to SD. From the truth table and the expressions, the logic diagram of 1 to 2 demultiplexer can be designed using 2 AND gates and 1 NOT gate as shown here. When the select line S equal to 0, the first AND gate A1 is enabled, while the second AND gate A2 is disabled. Then the data from the input flows to the output line y0. Similarly, when S equal to 1, the second AND gate A2 is enabled and the first AND gate A1 is disabled. Thus, data is passed to the y1 output. 1 to 4 demultiplexer. The next we discuss on 1 to 4 demultiplexer. The 1 to 4 demultiplexer has 1 input bit, 2 control bit and 4 output bits. The input data line goes to all of the AND gates. The 2 select lines enable only one gate at a time and the data appearing on the input line will pass through the selected gate to the associated output line. The truth table of 1 to 4 demultiplexer is given here. From the truth table, we can derive the Boolean expression for each output term. Then we get the logical expressions for different output terms as y0 equal to A complement B complement D, y1 equal to A complement B D, y2 equal to A B complement D and y3 equal to A B D. Look into the circuit diagram of 1 to 4 demultiplexer. The input bit is labeled as data D. This data bit is transmitted to the data bit of the output lines. This depends on the value of AB, the control input. When AB equal to 0 1, the upper second AND gate is enabled while other AND gates are disabled. Therefore, only data bit D is transmitted to the output giving y1 equal to data. If D is low, y1 is low. If D is high, y1 is high. The value of y1 depends upon the value of D. All other outputs are in low state. If the control input is changed to AB equal to 1 0, all the gates are disabled except the third AND gate from the top. Then D is transmitted only to the y2 output and y2 equal to data. As we have seen in multiplexers, there are different types of demultiplexers also. They are 1 to 8, 1 to 16, etc. This type of demultiplexer is used on integrated circuits as dual 1 to 4 demultiplexer. Mean to that it contains two 1 to 4 demultiplexer blocks where each demux accepts two binary inputs as select lines and 4 different active low outputs. Both demultiplexers will have their own individual set of select lines. So, they can act as independent demultiplexers. Note that each demultiplexer consists of dedicated enable signal which is treated as a data input for the demultiplexer operation. The enable pins are active low, the outputs are active low, that is they are high by default. So, if the enable pin is high, all the outputs are high, and if enable is low, then depends on the value of select pins, the corresponding output becomes low. 1 to 8 demultiplexer. The next type of demultiplexer is 1 to 8 demultiplexer. In a 1 to 8 demultiplexer, there are total of 8 outputs y0, y1, y2, etc., y7. 3 selection lines S0, S1 and S2 and a single input A. On the basis of the combination of inputs which are present at the selection lines S0, S1 and S2, the input will be connected to one of these outputs, not the input and output bits of the truth table. The select inputs take values from 0, 0, 0 to 1, 1, 1. And in the output columns, when input is 0 0 0, we enter A for y0 and 0 for all other output lines. In the same way, input is 0 0 1, output is y1 equal to A, and for the last entry, if input is 1 1 1 and the output is y7, which is equal to A. From this truth table, you can derive the Boolean expression as y0 equal to S0 complement S1 complement S2 complement A, y1 equal to S0 S1 complement S2 complement A, y2 equal to S0 complement S1 S2 complement A, and y3 equal to S0 S1 S2 complement A. Then y4 equal to S0 complement S1 complement S2 A, y5 equal to S0 S1 complement S2 A, y6 equal to S0 complement S1 S2 A, and y7 equal to S0 S1 S2 A. Let us draw the circuit diagram. The input A is fed to all AND gates, and 3 select lines either in complemented or uncomplemented form are connected to each AND gate along with A input. Depends on the value of select lines, one of the AND gate will be active and produces the output. The circuit diagram of a 1 to 8 demultiplexer is given here. Then next, we discuss on 1 to 16 demultiplexer. 1 to 16 demultiplexer. In a 1 by 16 demultiplexer, there are total of 16 outputs, y0 to y15, 4 selection lines S0, S1, S2 and S3, and single input A. On the basis of the combination of inputs which are present at the selection lines S0, S1 and S2, the input will be connected to one of these outputs. One can write the truth table as we did for the previous demarks. Then from the truth table, we will be able to derive the expressions. The truth table is here. Then from this truth table, we derive the logical expressions. Y0 equal to A S0 complement S1 complement S2 complement S3 complement, y1 equal to A S0 complement S1 complement S2 complement S3, etc. You can derive all the equations up to y15, which is equal to A S0 S1 S2 complement S3. We can draw the circuit diagram with 4 input lines and 16 AND gates that produces the output. Here is the circuit diagram of 1 to 16 demultiplexer. A decoder with an enabled input can act as a demultiplexer. A decoder can function as a demultiplexer if the enabled line is considered as the data input line and A and B are taken as selection lines. The decoder with enabled input and a demultiplexer is shown here to understand the similarity. Actually, the decoder and demultiplexer operations can be obtained from the same circuit. It is the enabled input that makes the decoder circuit a demultiplexer. The diagram is given here for your reference. Applications of demultiplexer. Data from a single source can be distributed or connected to multiple destinations by using a demultiplexer. Since demultiplexers are used to select or enable the one signal out of many, these are commonly used in microprocessor systems and computer control systems. Let me list a few more applications. It is used in data routing for selecting different I/O devices for data transfer. Another application area is memory decoding. Other than these, demultiplexers can be found in a wide variety of applications such as synchronous data transmission systems, Boolean function implementation, data acquisition systems, combinational circuit designs, automatic test equipment systems, etc. It is also used in security monitoring systems for selecting a particular surveillance camera at a time. One of the popular and relevant application area of demultiplexer is data communication system. Usually, the communication systems are bidirectional in nature. They function in two ways, transmission and reception. So, in most of the cases the multiplexer and demultiplexer work in combination. A multiplexer is so important in a communication system because it helps to transmit multiple forms of data like audio, video and other forms using a single line. This makes the transmission efficient and cost effective. The demultiplexer receives these output signals of the multiplexer and converts them back to the original form of the data at the receiving end. The figure given here shows the working of a mux and demux through a transmission channel. They work in pairs. Another important application of demultiplexer is reconstruction of parallel data. It reconstructs parallel data from the input serial data stream. It is also used in ALU circuits. The output of ALU can be stored in different storage units with the help of a demultiplexer. The output of ALU is the data input to the demultiplexer. Each output of demultiplexer is connected to different storage units like registers. Let me summarize. For the last few sessions, we were discussing on different types of combinational circuits. This is the last one, demultiplexer. A demultiplexer performs the reverse operation of multiplexer. In this session, we discussed about different types of demux like 1 to 2, 1 to 4, 1 to 8 and 1 to 16. They are logic circuits, Boolean expressions and some important applications of demultiplexers. In the next session, we will meet again with the topic sequential circuits. Thank you for watching. Bye.